There you go. You know, yesterday, Katie, we said we wanted to record for you, and your friend said, "Forget Katie."
That was me. Yeah. No, I said Katie can handle it.
Okay, so we are done with cotangent. Definition of cotangent inverse. Chanel, what do you want to write on definition of cotangent inverse?
Say y or x equals cotangent y.
Which means we have to solve for y, which is y equals f inverse of cotangent inverse of x. Okay. We are going to try to state the domain, the range, and put it back to the unit circle. Right, class? Yep. Okay, here we go. Domain. Negative infinity to infinity. Do you guys agree? Okay. Negative infinity to infinity. Ryan, what is the range, bud?
0 to pi.
Okay. Yes, sir. Let's put it back to the unit circle. If it's 0 to pi, what two quadrants is then cotangent inverse restricted to? First and second. 1 and 2, because 0 is right there, pi is right here. Then method 1, we're going to do exactly the same thing as we did before. Okay? And then when we get to method 2 is when I'm going to ask you to put your pencils down. So we said 0 to pi, right? So here we go. Pi is right here. Pi is on the top. Asymptotes right away, so we'll graph the original first. The reason I like to graph the original first is because then I just reflect it. I don't have to worry. Okay. One mark, it's in between pi over 4 and pi over 2. Is that okay to say? So pi over 4 comma 1. So can I put it in between pi over 2 and pi over 4? Yeah, okay. And then pi over 2 is 0. Similarly, we have negative pi down here. And 3 pi over 4 is negative 1. So here's my original that's restricted. Okay, so this is y equals cotangent of x restriction. Then now, asymptotes. Let's graph its inverse. Okay. Alex H., can you tell me where we should put our two asymptotes for its inverse?
At pi and negative pi.
At pi and negative pi? Did you guys agree? At pi and negative pi, the two asymptotes?
0.
At 0, when you horizontally. And posit pi? Are those two correct asymptotes? Then give me one dot, please. Give me the first dot, okay? Alexandre, give me the first dot for its inverse.
Pi over 2 and 0.
Pi over 2 and 0. That used to be my original dot.
What?
That was
0
my
and pi over 2.
0 and pi over 2. Okay, so 0 and pi over 2. Perfect. One more dot. Edison, give me one more dot that's not already given. One comma pi over 2. Sounds good. Okay, so 1 and comma pi over 2 right there. Okay. And last and final dot, Lucian.
At negative 1 and
3.
3 pi.
Excellent.
3 pi over 4.
Good job, Lucian. Okay, so does it look like it's symmetrical over our line, y equals x? Yeah, right? If it's... All right, so that's what the inverse looks like, a rainbow. I'm going to write y equals cotangent inverse of x. Okay, once you're done writing that down, put your pencils down. Then, because I need you to understand method 2 really well before you write. Don't write it if you don't understand it. Pencils down when you're ready. I'll wait for you. There's no rush. Are you guys good to go? Okay. Method 2. Okay. All pencils down? No? All right. Method 2 is when I'm going to use tangent inverse. So again, don't write anything. I will leave this up for you to copy later. I'm going to use tangent inverse to apply to cotangent inverse. As you remember, we graphed out tangent inverse already. So let's go. You don't have to do anything. You just have to look. I have to flip back quite a few. We did a lot, didn't we? Here we go. We graph this out. Can you see tangent inverse is the pink one? Or is that even pink? What are the 3 dots under tangent inverse? 0, 0 is one of it. What else? 1, comma, 504. What else? Negative 1. Okay, so I'm going to go back to cotangent inverse and do that. We did a lot. I just have to flip a lot. Okay. So tangent inverse was, we had an asymptote at pi over 2. Is that correct? Then we had an asymptote at negative pi over 2. And you told me one of the dots was at what? 0, 0. Great. What else?
1, pi over 4.
1. So this is a pi over 2. So pi over 1, pi over 4. What else? Negative 1 and pi over 4. Okay. So this is y equals tangent inverse. Copy it over. Okay. Now I'm going to pinch this in so we can see the rainbow color cotangent. The curves are similar. Would you agree? Except they're not in the right direction. How would I get tangent to look like cotangent? What would you do first? I'm going to write step by step. Trey?
Shift it up 1.
Shift it up. When you say 1, what do you mean, like 1 tick mark?
No,
What do you say first?
I would say you should fit pi over 2.
So flip it?
No.
shift it
Up.
up.
Shift it up,
Pi
okay.
over 2.
Shift it up by,
Pi over 2.
Pi over 2.
But then,
okay. Have I shifted up? Yeah. Okay, so far. What else would you? Okay, so I'm going to write that down. Can I reflect it as well? Would you eventually have to reflect it?
can you just do negative 10?
Okay. Could I, because right now, can you see the curvature is not going the right way as cotangent inverse? What would you reflect? Okay. Actually, technically, it's either, right? Would you agree it's either reflection? So 1, reflect, don't write anything, just pay attention, over y-axis. If I reflect over y-axis, would you agree it's now y equals negative tangent inverse of x? Is that the correct location for reflection of the y-axis?
Yeah.
Then I'm going to draw that picture really quickly. Whatever's on the right is now on the left and vice versa. No, I have not. Oh my gosh, yes, that'd be amazing. Thanks, Miss Gaddison. She's gonna make a test for me, so excited. Okay, so I'm going to graph this out. This is the first reflection. Then step number 2, one of you mentioned that, what do you need to do on step 2? Up, right? Translate up. How much though? Oh, thank you. Up by pi over 2. So y equals negative tangent inverse of x. Is that a plus? Is that a minus? Plus. Outside the quantity, inside the quantity? Outside. Awesome. So now I'm going to move it. So I'm going to move the asymptotes. It used to be at negative pi over 2 to pi over 2, so now it's going to be at 0 and pi. Yes or no? Yes, okay. Let's move my dots. It used to be at 0, 0, so now it's going to be 0 pi over 2. It used to be, what, 1 comma Negative pi over 4? Is that right? On my dots right here? Is that okay? I'm going to move it up a pi over 2. So would you agree it's like right there? I'm going to hold them on tight before I go any further. True or false? Okay. Then the other dot used to be right here. I'm going to move it up. So it's going to be right there. Are those close enough? Approximation? So, okay, so check out that green curve and our rainbow cotangent curve. Are they, don't do anything yet. Are they about the same?
Yes.
Okay. So here's what we have. We took tangent inverse, we reflected it, and then we move it up. So now this curve is exactly the same as cotangent. So that's what we're going to say. We're going to say, hey, you know what? Cotangent inverse of x is exactly the same as that piece. But because to make things prettier, I'm going to move the pi divided by 2 in the front minus tangent inverse of x. The reason we're doing this is because on your calculator, do you have a cotangent inverse button? No. What are the only inverses that you have? Most calculator, I would say. If you have the sine inverse, cosine inverse, and tangent inverse, there isn't a cotangent inverse of most calculator. So that's why we have to prove it, that this is a way to obtain cotangent inverse. All right, copy that down. Then we are going to use it right away. Only cotangent, that's why we took longer. Yep, the rest of them, you don't need to worry about shifting anything. And the reason cotangent is also more difficult, what's the restriction on cotangent inverse for two quads? 1 and 2. What's the restriction for tangent inverse? They're not even the same restriction. Okay, so that's why cotangent has a different formula to get it. What's the restriction for sine inverse? 1 and 4. What's the restriction for cosecant inverse? Are they the same restriction? Yes, I don't need to worry about anything else. Okay, it's the same as the cosine and secant. So, how did we get this formula? By comparing and using what? What did we use? Transformation from tangent inverse. Okay. Because you're going to ask me later, where did this come from? I'm going to say, take out your notes on page 8. If you're done copying, because I'm going to write really fast, just for kicks, go do example 3. And use a pencil just in case you're wrong. Example 3, yeah, because it's just calculator. It's okay if you don't know how to get it yet. Just do what you don't know. What did the calculator say, Trey?
Error.
Error. So funny. I know, right? The newer calculator calculators have like cotangent inverse. You don't have to worry about anything. Like the new calculators allow you to cheat. No, you don't. See? What a dilemma. So, is the calculator broken? No. Reset it. Reset it just in case. Your backpack hits the funny button. Anyone not done copying this definition yet? Okay. Yeah, I know where it is. I don't know.
I got this one.
Let's go to 3 because you guys already know calculator. I don't want it. Okay. On 3, it says use a calculator and round. Does it say round at all? 2 decimal places. The first question is cosecant inverse of 2. Let's tell me the domain of cosecant inverse really quickly. What's the domain of cosecant inverse? The domain of cosecant inverse. Negative infinity all the way to negative 1, take a break. 1 to infinity. So is 2 in that domain? So 2 is in the domain, right? So technically, would you have an answer? Should you have an answer? Yeah, you should have an answer. You can do example 3 of the calculator. I'm sorry, negative 5. I lied. Negative 5. Is negative 5 in that domain?
Yeah.
So technically, would you have an answer? Sure. How come the calculator said it doesn't work? Yeah, is there a cosecant button? No. No. How would you do it? How would you attack it? Download cosecant? By the way, can you even do that?
Yeah.
Hey, listen, you guys definitely would know more about technology than I. I just know what you tell me. Ready? Okay, let's go to 3 since your calculator's out. Use the calculator to find this. I'm gonna write this and then I'm gonna blame the calculator. And then I'm gonna like this. Cross it out and tell yourself, don't ever do that again. Okay. That's okay, because it's always good to make mistakes, right? Here we go. Cosecant inverse. Would you agree whatever the answer is, it will be an angle? Let's give it a theta, okay? We're going to go, I'm out of space, so can I just write up here? Cosecant inverse of negative 5 equals some angle. And this is why we do what we do. I'm now going to try to compose both sides. Okay. Would you agree that negative 5 equals cosecant regular of negative 5? I'm sorry, theta. What am I saying? Theta. Is that okay still?
Yeah.
Now, from here, you can do multiple ways. I can convert that to sine. Is that still okay? Yeah. So negative 5 equals, cosecant is 1 over sine, not its inverse, okay? Is that still okay? Then from here, can I flip it? Can I flip the right side? If I flip the right side, can I make it into sine of theta? It's an equation. If you flip the right, you need to flip the left. So can I make it into negative 1/5? Then now, can I compose both sides by sine inverse? That's right. So sine inverse, y'all, is of negative 1/5 equals theta. So this is what you need to enter in, right here. So what are you really taking the reciprocal of? The whole thing? Or just the ratio inside? Yeah, so highlight that piece. Now punch it in. You should have a negative answer if I'm correct. Negative 0.2 because cosecant is restricted in quads 1 and 4. It's negative 5, so the answer should come from quad 4, which is negative 0.2 radians. So theta is Negative 0.20, since it says 2 decimal places. All right, then you do B. What are you going to punch in? Those things? Amy Z, tell me what you're going to punch in.
Oh, I did the cosine of 1/3.
Very good. And your calculator says what? 1.23. Someone confirm that with me? Yep. Cotangent inverse. Do we have a special formula for it? Okay, what do we start with? Pi over 2. What else? Minus? Minus what? Tangent inverse of what? Of x. What's x?
Negative.
Right. Do I need to flip anything at all for tangent? I mean cotangent here? Nope. All right, punch it in. So Marco, give me the answer when you're ready.
Sorry, I don't mind vote in degrees.
Yeah, I know. Because earlier we were working on the thing in degrees.
Two
2.84. Someone confirm?
Yes.
Yes, okay. So now you know how to find inverse of all functions in with a calculator. Let's go back to non-calc, which is example dos. 2.84, Trey. Did you get that one though? No. Did you put, Trey, did you put parentheses around pi over 2? 2.85? Oh, 2.85. What's the third digit after that decimal? 8. Yep, then round it correctly. 2.85. So Trey, let me know again to see if you come up with that. Are you in radians? Okay. Okay. Is it the parentheses?
Yes.
Oh yeah.
Or no, I put pi minus 2 instead of pi over 2.
Yeah, that totally messed you up. So we're going to do the same thing, except this time, no cal. Okay. Same thing, same concept, except you can't use a calculator. So cosecant inverse of 2, would you agree that it's going to be some angle? Let's call it theta. Then I'm going to compose both sides with cosecant. So 2 equals cosecant of theta. Because we started out with an inverse, y'all, this theta would have to come from which quadrant? 1, right? Because it's a positive 2. Can you agree that it can only come from 2 places, quad 1 and quad 4, but it's positive, so it can only come from 1. So 1 and 4, but it's positive, so answer has to come from there. So whatever angle it is, it has to be positive. Okay. Right away, some of you already know cosecant of something is 2. Or I can write it in sine. 1 over sine of theta equals 2. Can I flip that? Yeah? So sine of theta is technically equivalent to? Now do you know it? So theta is pi over 6. You're right. Okay. Right, you try B. Yes. Because you already know what theta is. Exactly. You should know when we do the circle. Sine of what? Yeah. Yeah.
Oh, okay, so if you know that, you don't need to do anything else. Oh, okay.
On the test and on your homework, pencils. Anything that, just anything else. Once you have an answer to B, can you talk to your peeps? And by the way, if you know it already, do you have to do all of this work? No, this stuff right here is just to recall your memory from the unit circle. But if you know secant inverse of 2 is right away pi over 3, then you just write it down. Yep, write it down. How about C? Okay. Let me do B together, and then we'll come back to C. Now, if you don't know, or not super confident yet, can I set it equal to theta? Then I'm going to write 2 equals secant of theta. And if you're not confident with secant, what can you use? Cosine. So 1 over cosine of theta is 2. Can I flip it? So cosine of theta, it's 1 over 2. So by now, should you recognize this theta? Pi over 3. Okay, cotangent. What would you do with cotangent inverses? What are you going to use? That equation. All right, what's the equation you're talking about, Trey?
Pi over 2, not minus 2. Minus tangent inverse of the
Whatever that is, okay? In this case, it's this. I do expect you to know tangent inverse of negative rad 3. Let's first narrow down to the quadrants. What 2 quadrants can tangent inverse be in? 1 and 4, okay? Now remember, this is tangent inverse, so 1 and 4. Because it's negative rad 3, the answer has to come from what? 4, okay? Tangent inverse of negative rad 3 is what reading? Negative is right. Negative what? Pi over, not 6, but pi over 3. Why not 2 pi over 3, or in this case, 5 pi? Yeah, because you can't go past that guy at the top, right? So you have to go, okay. So we're going to write pi over 2 minus, what's that answer again? Negative pi over 3. Can I leave my answer like that? No. What would you do from here? Combine. What's the common denominator? 6. So this is 3 pi over 6. And what's this over here? 2 pi. So, ooh. Chanel, can you hit the keyboard for me? It's sleeping on us. Yeah. It's sleeping on the job. Thank you. So final angle is 5 pi over 6. But let's verify that really quickly. The original question was cotangent, right, class? Cotangent was restricted in 2 places. Quads 1 and 2. It's negative, so the answer has to come from what? Which quad? 2. Is 5 pi over 6 in quad 2?
Yes.
We're good. Yeah.
Why is the inverse of cotangent only allowed in first and second quadrants? Is that something we have to know?
Isn't that where we cut it off? Remember, all these quadrants is where we decided earlier to cut it off.
Oh, yeah, I remember.
Yeah. Even tangent, right? Negative pi over 2 to pi over 2, because that's where we decided to cut it off for 1 to 1. All right, cotangent inverse. What do we write down? Pi over 2. Take away. Tangent inverse of negative 1. Do you know what tangent inverse of negative 1 is? What is it? Negative pi over 4. I'm going to hold on tight so you can disagree. Common denominator is 4. So that's going to be 2 pi over 4 plus, right? A pi over 4. So this angle is in. Now let's double check that with the original. Cotangent inverse is of negative 1. It has to come from what quadrant?
1 and 2.
1 and 2, because it is negative 1. It has to come from quad 2, right? It's 3 pi over 4 in quad 2. So cotangent of 3 pi over 4, is that negative 1? Yeah, okay. That's what I'm going to stop for today. Yeah. We have example 4 left, am I right?